In this video, let us talk about inheritances and enumerations in C#. Let me start with interfaces. Interfaces in C# lets us create an implementation rule for objects and methods. Let's go ahead and create our project for this. And open it up. Let's say we still have our class car. And we have these fields declared for it. We have the make, the model, and the year of manufacture. And what we want to do now is to have a strict implementation for this. The interface lets us, say for example, whenever we declare a car, we want to ensure that we always call the drive method and the stop method. Instead of having to just create a car just like this, what we'll go ahead and do is create an interface. Let's call that iCar. It's general best practice to denote an interface with the I keyword. So we have iCar denoting the interface for a car. And now we want to say have a void of drive. We can pass in arguments here also if you want to, and we can make it return anything. For example, int fill up. We can make it return a value, and we can even pass in arguments just like this. But let me ignore this one. We only are concerned with stop. Let's say stop will return the fuel level of the car. So after we stop, we'll get the results of the operation. And when we drive, we'll increase some values. So in here, let's actually introduce a new variable. So let's make that a public double of fuel level. All right, and when we drive, we'll decrease the fuel level. When we stop, we return the value of the fuel level. Let's actually now go and implement this. To be able to ensure that the class is enforcing the rules of operation, we will make it inherit from iCar. And if I try to build this, I should get an error that class car does not implement the interface, the methods of the interface iCar. Let me actually do a dotnet runs instead of a dotnet build. Okay, you see, car does not implement the interface member iCar.drive and iCar.stop. So what I can do is make this use this method. So I need to declare a void of car, make that public, drive rather, and then also stop, which returns a double. If I try to run this again, sorry about that, I should be able to run it, but I've not actually created any raw implementation of this, so I'll need to still create instances of my classes. Now there's a little bit of error. Not all code paths return a value, yes. So here I need to return a value. So here I want to return fuel level. Let's try that again. we're fine. So for now, let's ignore these warnings. But another thing I could actually do, instead of having to declare this way, I can actually make it become a standard get set operation. So I could put in a getter and a setter over here. So what this does in essence is that it tells me that I'm able to retrieve value using the get keyword and set a value using the set keyword, and assign a value rather using the set keyword. So if I do this way, this warning hopefully should go away, because I've actually declared this now in the right construct that it should be in. And you see, it built, and the warnings are no longer there. So this is actually the right way of declaring class fields on the minimum. There's the full one, there's the short one, and there are ones that you can customize for yourself, but let's take this at a very basic level. Now that I've declared my car and make it inherit from iCar, I can now go ahead and create a new car. And then of course, put in the values in there, and I'll say the make is, sorry about that, Toyota. And my Toyota today, you can guess what kind of Toyota I'm driving. I'm driving a Toyota CHR. And then the year of manufacture is 2020. And the starting fuel level is 15.3 liters. And then one thing I can also do here is I can set a constructor to say, hey, when I create a new instance of this dude, I want to make it start with a value. So for example, if I don't declare any fuel level, I might say I want this level to be set to 5, so I could put a default value of 5 inside here. So this way, even if I do not declare the fuel level, I'll still get 5.0 as my fuel level. Now, this is done and ready. Now I can call my car dot drive normally. I could also call my car dot stop. Because this is returning a value, I can actually assign this to a variable. Okay. Assign this to a variable. And then do a console dot write line the current status of the car, the current fuel level of the car rather. Make an interpreted string in here. Fuel level equals, then put in my car dot fuel level, then end the statement. I'll need to now actually go ahead and create implementations of my methods. So for example, when I drive, I need to reduce the fuel amount. When I stop, I need to terminate that. So let's go over here and finish this up. So I'll do a console, the write line, driving, and then reduce the fuel amount. By 0.2 maybe. All right, and let me modify this a little bit also. Right, so I can drive, I can stop. Let me actually drive some few times more so my fuel level can reduce a lot. You know what, I'm gonna copy this twice again and then paste it back in. So I drive it again and I stop it again. So we'll see actually that the values are reducing as we call the method. So here I'll do a .NET run again and see that work. There's a little bit of problem now. My bad. I cannot declare this again since I already declared it once. I can just call the value out. Now that bit is done, and as you can see, my fuel level when I stopped the first time is 14.1 liters, and when I increased it the other time, when I drove again and stopped, it reduced to 13 liters, 13.7 liters. That is interfaces for short. Now let's look at enumerations. Alright, so let's say we do not want to declare different kind of cars, and we want to say they're different kind of cars: hybrid, diesel, petrol, electric. Let's even look at transmissions: automatic and manual, maybe even the semi-automatic one that is called. So let's now say we want to define this set of values that have a predefined set of members. Instead of having to declare them as strings, we can actually use enumerations to walk through them. And we declare enumerations this way, very simply. Transmission. Let's say we want to use an enumeration of transmission, and then we just declare automatic, manual, and then semi-automatic. Those are our three kind of transmissions, and then we can go ahead and define this in here. Then we define this type as transmission. Transmission type. And we can declare the transmission here now and say the transmission type of this vehicle is equal to a transmission dot automatic. We can make it manual also if you want. So let's actually ignore all these drive methods for now, and then just output the details of the car to the console. So what I'll do in here, I'll have an interpolated string, and for that I'll put in all the details of my car. So I'll say my car.make, then pass in also my car.model, my car.year, as a transmission as a or an, then put in the transmission, all right. My spelling is wrong right there. Okay, I think that is good to go. Let's test that out and run. There's a little bit of problem now. Am I missing a spelling? Transmission. My spelling is very bad now. Let me run that again. and we should see the output of our car giving us my Toyota CHR 2020 as an automatic transmission. We can actually make this dot to lower because it's supposed to be in a statement. We need to convert it to string first and then make it lowercase. And let's try that out. Now there's a bit of problem. Oh, I'm missing parentheses here. Let me run that again. Great. And that is a little bit of enumerations and interfaces in C#. I hope you liked it. If you like this video, please give it a thumbs up and also subscribe to my channel and hit the notification bell so you will get notifications when I post new videos on this channel. See you in another video. Goodbye.